Projectile motion check 1. In this question, Mr. C is parachuting or skydiving from an airplane on a level flight path traveling at 350 miles an hour, 1,000 meters above the ground. In part A of this question, we want to know how far from the landing zone Mr. C should jump out of the plane. In part B, we ask, if Mr. C gets cold feet and jumps 5 seconds late, how far does he miss the landing zone by? For part A, we know that the plane Mr. C is in is 1,000 meters above the ground. This is going to serve as our delta y for this equation. What we want to know is, if he jumps out of the plane, he wants to hit his landing zone here. We need to solve for delta x in order to give that answer. To solve this, we're going to have some variables. We'll have velocity initial x, which is his velocity as he jumps out of the plane, velocity initial y, as well as acceleration x and acceleration y. Velocity initial x goes across since it's the velocity in the x direction. Velocity initial y is down since it's velocity in the y direction, along with each respective accelerations. Now we know velocity initial x is equal to 350 miles per hour. We do not know, or we do know velocity initial y is 0, since he's not moving. Acceleration x is 0, because this is projectile motion and velocity in the x direction does not change. Acceleration y is negative 9.8 meters per second squared, because it's acceleration due to gravity. In order to solve for our delta x, we're going to use the equation delta x equals velocity x times time. Now, the problem is, for our velocity x here, we're going to need it in meters per second. Our velocity x right now is in miles per hour, but we can solve for this using some stoichiometry. In order to solve for this, we know that 350 miles per 1 hour is what we start with. Now, to just go from miles to kilometers, we have to begin by multiplying by 1 kilometer over 0.6213 miles. Now this allows us to cancel out our mile units to leave us with kilometers per hour. In order to get to meters, then, we solve for 1,000 meters in 1 kilometer. This now leaves us with our correct unit on the top, but we still have hours on the bottom. In order to get from hours to seconds, we do 1 hour over 60 minutes, which allows us to cancel out hours. We now have meters per minute. Finally, we do 1 minute over 60 seconds to get our correct units of meters on the top and seconds on the bottom. Now, in order to solve for this, you multiply across on the top. When doing that, you end up with 350,000 meters. Similar on the bottom, you end up with 2,232.68 seconds. After dividing, you'll find that you have 156.48 meters per second. Now we know that our velocity x is 350 miles per hour, or in order to put it into this equation, 156.48 meters per second. So we can begin writing out this equation. Now we don't know our time yet. In order to find our time, we're going to use the delta y equals velocity initial y times time plus one half acceleration y times time squared. We know that delta y equals 1,000 meters. Now, since delta y is the change in y, and Mr. C is jumping out of the plane, he'll be moving down, so our delta y is in fact negative 1,000 meters due to his direction. Velocity initial y, as we know, is 0, times time, which is what we're solving for, plus 1/2, and now this is our acceleration y, 9.8 meters, negative 9.8 meters a second squared, due to gravity. And finally, once again, time squared. Initially solving, we see negative 1,000. I'm going to put a line here for sorting. Equals 0. 0 times time is 0. Plus 1/2 times negative 9.8 is negative 4.9 meters per second squared times time squared. Now, in order to get time squared alone, we know that 0 plus the rest is just negative 4.9 meters a second squared times time squared. This part just cancels out. We now divide negative 1,000 by negative 4.9 meters per second squared to give us 204.08 seconds squared. I'm going to double check that real quick. 1,000 divided by 4.9 is 204. Equals time squared. Now we square root both sides to cancel out, and we get 14.29 seconds is our time. So now we can finish our equation up here to get 14.29 times 156.48. Solving for our delta x, we get delta x equals 2,236.099 meters. This is how far Mr. C will travel once jumping out of the plane, and how far he should jump out before his landing zone. Now for part B of this question, since we already know our time, we don't need to solve for that again. However, we are going to be using our delta x equals velocity x time equation again. However, with one tweak, since he's jumping out 5 seconds late, we know our velocity x is the same, 156.48 meters per second. However, we're doing 5 seconds late, so we have 14.29 plus 5 seconds, which gets delta x equals 156.48 meters per second times 19.29 seconds. Solving for this, we get delta x equals 3,018.5 499. In order to solve for how far he'll miss his landing zone by, we subtract our first delta x that we solve for. So minus 2236.099. We get 782.4 meters. If Mr. C jumps 5 seconds late, he'll miss his landing zone by 782.4 meters.